Something incredible is happening in space right now. 4 astronauts are on their way to the moon, and they launched just 2 days ago. The mission is called Artemis 2. It launched from Kennedy Space Center in Florida on April 1st, 2026. But here's something many people don't realize. They are not going to land on the moon. So what exactly are they doing up there? Flying around, not landing. The astronauts are traveling in a spacecraft called Orion, sitting on top of one of the most powerful rockets ever built, called the SLS, Space Launch System. Instead of landing, the spacecraft will follow a path called a FreeReturnTrajectory. How does this invisible U-turn actually work? Think of it like this. Imagine you are on a skateboard, racing at full speed toward a massive spinning merry-go-round. You don't plan on jumping on and staying. Instead, as you fly past the edge, you reach out and grab a handle for just a second. Because you are moving incredibly fast, the merry-go-round isn't strong enough to pull you to a stop or keep you spinning in circles. Instead, you feel a powerful tug that curves your path. By the time you let go, you've been swung around in a wide arc, heading right back in the direction you came from. This is exactly what the Orion spacecraft is doing. The moon acts like that giant merry-go-round, and its gravity is the invisible hand reaching out to pull on the ship. NASA's scientists don't aim the spacecraft directly at the center of the moon. They aim for its shoulder, a specific point just off to the side. As Orion passes behind the moon's gravity pulls on it, forcing its straight path into a U-shape. The key is speed. The spacecraft is traveling much faster than a literal speeding bullet. At that high speed, the moon's gravity is simply not strong enough to catch it and hold it in orbit. But here is the real secret. It's all about the brakes. This is a deliberate choice by NASA. To stay, lunar orbit. If the mission were to land on the moon, like Artemis 3 will, the astronauts would have to turn the ship around and hit the brakes by firing their engines. Only by slowing down can they allow the moon's gravity to trap them in a circle. To return, Artemis 2. For this mission, they keep their high speed. NASA has calculated the path so the moon's gravity does just one job. It bends the ship's direction 180 degrees and slingshots it back toward Earth using its own momentum. This free return trajectory is chosen because it is incredibly safe. NASA calculates the speed and angle before the ship even leaves Earth. This means that even if the spacecraft's engines were to fail completely halfway there, the laws of physics would act like an automatic pilot. The moon's gravity would naturally swing the astronauts around and point them home, no fuel required. It isn't just a flight, it's a masterpiece of physics, a powerless U-turn using the gravity of another world. Now that we know how they are getting there and back, let's look at the incredible things they'll see. The closest the crew will get to the moon is about 4,000 miles from the far side surface. That might sound far, but compared to the 240,000 miles they traveled to get there, it's incredibly close. The big moment happens on Monday, April 6th, when the astronauts will fly around the far side of the moon. Something extraordinary will happen then. For about 30 to 45 minutes, their radio signal will be cut off. The moon itself will block all communication with Earth. They will be completely alone, further from home than any human beings in history. In fact, this mission will break a 50-year-old record. The previous record for the farthest humans have ever been from Earth was set by the Apollo 13 crew in 1970 at about 248,655 miles. Artemis 2 is expected to go even farther. Why not just land? If NASA can fly all the way to the moon, why not just go down and land? Think of it like learning to swim. You don't jump into the deep end on your first day. First you practice floating, then kicking, then you try going underwater. Step by step, you build confidence and check that everything works before doing the hardest part. Artemis 2 is NASA's floating and kicking step. Before landing a crew on the moon, NASA needs to know that Orion's life support systems work, that the heat shield can protect the crew coming home. They'll be re-entering Earth's atmosphere at about 25,000 miles per hour, faster than any spacecraft bringing home a crew since the Apollo era, and that astronauts can handle the effects of deep space radiation and long-duration spaceflight far from Earth. Deep space radiation. Beyond Earth's magnetic shield, space is filled with high-energy particles, like invisible microbullets. They can pass right through the ship and damage human DNA. Artemis 2 is testing how well the ship's walls and special vests protect the crew from this invisible enemy. The heat shield. Coming home, the crew will hit Earth's atmosphere at 25,000 miles per hour. That creates friction so hot, it's like being inside a blowtorch. This mission proves the heat shield can handle that heat before we try a landing. All of that gets tested on this mission, so the landing missions can happen safely. What comes next? After the moon flyby on April 6th, Orion will head back toward Earth. The crew is expected to splash down in the Pacific Ocean around April 10th or 11th. After that, NASA will study all the data collected and start preparing for the next missions, which will eventually lead to humans actually landing on the moon for the first time since 1972. The astronauts will be completely cut off from Earth. No phone, no radio, nothing, while they fly around the far side of the moon. What do you think that silence would feel like? Leave your answer in the comments.